Good morning, students. This is Shivaji Patel. Welcome to Maths Chef YouTube channel. So today is the continuation of the chapter number 12, that is area related to areas related to circles. Circle, okay, areas, different areas, okay. So in first video, I have done how to find the area of the circle and circumference of the circle. That's all. Then here, how to find the area of the sector and segment of a circle. The region bounded by the sector, again the region bounded by the circle, right? That segment or circle, okay. So that one, so before going to that one, basic what circle is, the locus of a point moves in a plane such that the distance from the fixed point is same, constant, okay. So this is the called center and this is the called radius. This is O, this is P, okay. In the first class, you have to learn the meaning of chord, radius, diameter, circumference, the ratio of the pi. You also saw all these one, all that one, right? So now the sector and segment. How the segment is defined and sector is defined with respect to circle. Okay. The sector is the region bounded by the two radii. Right? Region bounded by the two radii. This is R, this is R. This is Q, this is capital. Okay. So this is called sector. This is called sectors. Okay. Sector you can write sector is OQR. OQR. Okay. I'll write OQR is the sector. Sector is OQ. OQR is a sector of the circle. By default, wherever you are using the sector, itself is a minor sector. Okay. By default, wherever you are using is called minor sector, means smaller area. Okay. In exams, in questions, by default, whenever you are using the sector, itself is a minor sector. Okay. This one is a minor sector. Minor, and remaining this area is called major sector. Okay. Our sector is the area, the region, the surface, second called also bounded by the one part of arc, part of the circle with two radii. Okay. Means you can call the part of the circle, part of the arc. The area, the region bounded means surface made by the part of the arc, this arc, the whole with center, the area between the two radii, okay, two radii, okay. This is called sector, minor sector, major sector. Minor means smaller area, major is larger area. By default, whenever you are using the sector, it is a minor sector, okay. Similarly, what is segment? Segment of a segment of a circle. Segment. Okay. So again, it's the circle. The chord is this is the center. This is the chord. Okay. This is O. This is P. This is the Q. Somewhere point A. Okay. The chord is okay. PAQ. Okay. PAQ is a segment. Again, by definition, the area, the region bounded by between the chord and the arc. Okay. Chord and corresponding arc. Here radii and corresponding arc. Here area between the chord and corresponding arc. So this one is called, okay, smaller area is called minor segment. Minor segment, and that one is called major segment. Okay, again by default segment is called minor segment. Here sector is called minor sector for the calculation purpose, right? So based on these conditions, let's see some examples. Okay, some derivations, formulas. Okay, for area of the sector. Okay, first one is how to find the area of the sector. Area of the sector. First one is area of the sector. Okay, the whole area. Okay, now the area of the circle is pi r square. Okay, area of the circle is pi r square. Okay. Length of the given as we have the four concept. First, area of the circle is pi r square. So pi r square is for what is the total angle of the for total angle of the circle that is 360 degree. Okay. So area of the circle is pi r square for total angle of the circle, that is 360 degree. Okay, this is the main concept. So what I am trying here, so for okay, here now I have some theta always. Okay, there are some angles being na. This is the part of the circle, right? That area is part of the total area of the circle. Therefore, see how to define. This is the very basic concept for commercial mathematics, also for this algebraic and arithmetic mathematics. Okay, let's see for 360 degree. Okay, the area is pi r square, where r is the radius. For 360 degree, area will be pi r square. Therefore, okay, for theta degree means we don't know the angle, how much. Okay, question mark. This is called cross multiplication. By cross multiplication, you can get the answer. 360 degree pi r square. For theta, how much we don't know. Theta means some angle. Okay, therefore this implies the required area is equal to, okay, change the terms here. First term, second term, no? First term, second term, numerator, denominator. Reverse it, okay? Theta by 360 into, okay, into what? This multiplication, pi r square, required area for the theta. Okay, simple is like that. Like na. Okay. In mathematics, in commerce, what you do? Okay. In commercial mathematics, what you do? If okay, for 10 rupees, 10 apple. Okay, 10 rupees, 1 apple means 10 apple, 5 apple. Okay, for 100 rupees, how much apple you will get? Question mark. Okay, for 10 rupees you will get 5 apple. For 100 rupees, how much you will get? It is easy na? 50, right? Answer is okay in our mouth. It is 50 rupees. But how we mathematically explaining here? So 10. Okay, 10 by. Okay. So for 10 rupees, you will get the 5 apples. For 100 rupees, you will get into 10. 500 is 50. So what I am doing, write the first one here. Take the numerator interchange. Multiply the right side. Second term divided by first term. Multiply the right. Okay, right number. So 10, 0, 0 get cancelled. 10 into 5 is 50. Apple will get for 100 rupees. That's the question. Okay. Similarly, for 360 degree, it is pi r square. For theta degree, we don't know. Take the theta numerator, 360 denominator, multiply the right side term. That's the answer. Okay. Again, okay, the area of the sector. For length of the arc of a sector is okay. Length of the arc. Okay. Length of the arc for the sector. Length of the arc of sector. Because the sector is there area between the radii and curve arc. Therefore, say again here, for what the area is, what the circumference is, 2 pi r. Total circumference is 2 pi r. This is for what? This is for 360 degree. This is for what? 360 degree. Okay. So now what I am doing here, for 360 degree, it is 2 pi r. Okay. How much do you want? You want for theta degree? Question mark. What is? Therefore, theta by method. Again, second term by 360 required. Okay. Required arc. Arc is, okay, arc of a sector, I am writing as S. Okay, arc of the sector is equal to theta by 360 into total circumference. Right? First formula is area of the sector is theta by pi r, theta by 360 into pi r square. Arc of the length of the arc is theta by 360 into 2 pi r. That's all. Okay. So this is over. Now the segment, how to find the, so again, say for area, for length you can find here. Okay. For arc length, this is the formula for segment also, for sector also. For area, this segment is different. Okay. How we define it here? Okay. This is over. Okay. So this is the circle. This is the center. This is the which one? Sector. Okay. We want to find the only area, this one. Okay. O P Q A. Okay. Let's see. O P A Q is a sector. Okay. Here O P A Q is a sector. And PAQ is a segment. PAQ is a segment. Okay. By default, we are using the segment word. That is the minor segment in the circle. Okay. So we know. Okay. We know the in theory in previous classes, the line drawn from the center to the chord. Okay, line drawn from the center to the chord bisects the chord. The line drawn from the center bisects the chord. The theorem we have means this becomes, okay, bisects means particularly, okay, perpendicular bisector. Okay, shortest can call the shorter distance also. The length, okay, so the shortest distance between the center and the chord is perpendicular bisector to the chord. By this theorem we have, so this OPQR, okay, here OR becomes is a perpendicular bisector, not only bisector, perpendicular bisector, okay. What is the perpendicular bisector? By the theorem we call the shortest distance theorem between the center to the chord is a perpendicular bisector. Already you know, see. Like that one, okay. This becomes there are two triangles OPR and OQR. So here OR is common. OP is equal to OQ and ORQ, ORP and ORQ is equal because by RHS all the sides and angles are equal. Therefore here by similarity or congruency, therefore by congruency, CPCT or congruency you can take, okay. CPCT angle POR is equal to angle QOR. Therefore, okay, what happens here? POR, no? Therefore, what are the given? This is theta, okay. What are the given is POR plus QOR is equal to theta, okay. So here you can write 2 POR is equal to theta because POQ is equal to QOR, same angle taking, okay. Therefore POR is equal to theta by 2 is equal to the parent angle QOR. This is very important, okay. Angle POQ is equal to angle QOR. Whatever may be angle, this whole angle, okay, whatever may be this whole angle, so this becomes theta by 2 and this becomes theta by 2, okay. So this is the basic concept here. From this one we can find the area of the, okay, area of the triangle again. So then becomes area of the triangle is area of the triangle OPQ is equal to 1 by 2, base into height, base into height, na? 1 by 2, the base is PQ into OA. By right now required area of this segment, okay. So here also you can do, okay, right, area of the segment, area of the segment, one of the segment is, okay, is equal to, I am writing, okay, area of the sector, area of the sector minus area of the triangle, okay. So this is equal to, I am writing area of the sector is OPAQ minus area of the triangle. Area of the triangle means AOPQ. This only for the notation for the understanding purpose. Okay, not in given the book. Area of the OPQ sector, area of the OPAQ, with including the segment, minus area of the triangle. Okay, this one what we have, area of the sector is what we call theta by 360 into pi r square, okay, minus, okay, what is this one is triangle, 1 by 2 into what the base is PQ, or the height is into OA. Okay. This I am writing in terms of trigonometry. Okay, just use the trigonometry ratios here. Trigonometry ratios. Okay. So what is the sin theta here? How to find this one length? Okay, na? This one we know only OP and OQ, but you don't know OR and PQ length, right? So what do you want here? Sin theta by 2 is equal to, okay, opposite by hypotenuse. What is the opposite here? PR by OP. Okay, this implies PR is equal to OP into, okay, sin theta by 2. Small notation, that directly fundamental formula. Okay, this is only for the understanding. Use this formula, use the almost every questions for this concept. Area of the sector and area of the segment. Only this formula. I am deriving that one. Okay. Similarly, okay, cos theta by 2 is equal to, take this, both angles are equal, have to take the anyone. Okay, theta OR by OP, OR by OP. This implies, okay, OR is equal to OP into cos theta by 2. So what is PQ is equal to? PQ is equal to PO plus, okay, PR plus RQ is equal to 2PR, therefore 2PR, na? Because PR is equal to RQ, 2PR is 2 into OP sin theta by 2. Okay, PQ is equal to 2 sin OP theta by 2, and OR is equal to OP cos theta by 2. Okay, this is the required formula. Okay, OR, this OR base into height. Okay, this becomes is equal to theta by 360 into pi r square minus 1 by 2 into, what is PQ here? 2 into OP sin theta by 2, okay, into OP into cos theta by 2. Okay, so by simplification, what we will get? Theta by 360 into pi r square minus 2 to get cancelled. What is equal to minus, okay, r square into sin theta by 2 into cos theta by 2. Okay, this is the actual diagonal formula. Just take the r outside, you can also, r is common, so you will get the answer also. But the fundamental formula for this one is, okay, therefore area of the segment, area of the segment, writing SG is equal to theta by 360 minus, okay, first of all, what is common here? R square is common, radius, theta by 360 into pi, pi into theta by 360 minus pi into theta by 360 minus sin theta by 2 into cos theta by 2. Okay, this is the required formula. Okay, in exams also I have to find the for this one to get the easy. So triangle is easy and this one is easy. Okay. Found to find only this area, segment area, because almost in questions they will ask the find the area of this segment, because that is the quite difficult task here. Area sector is very easy. By putting the data, we will get the area sector. For this one, we need to some alteration, means derivation. So this is the required formula. Area of the segment. This one is segment is equal to r square. Come, we have taken r square. What the remaining is pi into theta by 360 minus sin theta by 2 to cos theta by 2. Right? This one is the required answer. Okay. See, obviously, okay, only for the thinkers, imagination, logical thinkers. So area must be into length and breadth. So here r into r, we have r into r. Okay, but whole this one is the okay some arithmetical work of the some theta angle only. See how the angle is playing a vital role in defining the same area of the some part of the curve. Okay, so only find the this one radius, square of the radius, we can find the area, because which one which this is the area of the square, means square. Okay, that quadrilateral square. But see, if you multiply the some theta, some angle, the ratio of the angle, see this one theta will get, see value of the pi is 22/7. Theta will get, they will get theta and they will get the answer again. For sin theta by 2, sin 30 cos something they will give again given. Okay, so again we will get some integral, digital value, okay, decimal value or some real number. I think so here we will get the complete, not a real number, some which one rational number. Okay, only by multiplying the rational number we get the some area of the something else. Okay, this is the area of the square multiplying area of the, okay, the some angle of some angle. So what I'm doing is totally finally, if you multiply the area of the square to this some rational number, you will get the curve bounded by the circle or r of square. That's one thing. Okay, let me find the formula. Let's solve the question based on this one. Okay, this is the derived formula, very easiest question I think so. Only this one formula for this whole exercise. Only one formula. R square pi theta divided by 360 minus sin theta by 2 cos theta by 2 are remaining trigonometric values. Right? Let's see the examples. Here we have the, okay, first example is find the area of the center of a circle with radius 4 cm 30. Okay, question number 1, solved one. They are given here. Okay, this is 30 degree and this one is 4 cm. Also find the area of the curving major arc, major sector. To find the area of the sector of a circle. Okay, here we will find the area of the sector first, and area of the minor sector, major sector, and length of the arc, length of the arc this with respect to sector, and minor arc and major arc. Can tell minor arc, major with respect to sector. Okay, so solution here simple. Okay, what we have formula, so directly we can take the formula or we can take the again method, this one. For required formula for 360 degree, the area is pi r square. So for 30 degree, the area is how much? We don't know. But the formula is also same, theta by 360 into pi r square. So this is the applied mathematics, okay? Commercial like then ratio and proportions in profit and loss like that. For 60 degree it is pi r square. For 30 degree, how much? This one. Okay. So this implies 30 by 360 into pi into 4 square. Pi value is 3.14 they given. 3 ones are 3 ones are 3 ones are 3 twelves are. Okay. This becomes, okay, 22. Okay, then they have given 3.14 into 4 into 4 divided by 12. 4 ones are 4 threes are. Right? So this becomes 4 ones are 4 threes are. This becomes 4 into 4, 16. 4 into 4, 16. 4 into 1, 4 plus 1, 5. 4 into 12, 3. 12. 12 by 3. And this becomes, okay, 3 into 4, no? 4.18 nearly square centimeter. cm square. Okay, 26 is there. 2 remain. 26. 8 into 3, 24. Again 2. Again it goes. Okay. 4 into 18 square meter. So you can put the value here also. 30 by 360 into 3.14 into 4 into 4. Same. This concept will repeat here. Okay, that's what I'm doing here. So area of the sector. My sector is this one. What about the area of the major sector? Okay. Area of the major sector. Major sector is equal to, okay, area of the circle. What is the answer? Pi r square. Area of circle minus area of sector. Okay, for the area of circle is pi r square minus what the area of this one is, okay, theta by 360 into pi r square. Okay, simple derivation. Pi r square is taken outside common. 1 minus 30 by 360. Okay, 3 ones are 3 ones are 3 twelves are. So this implies pi, okay, 3.14 into 4 into 4 into, okay, 1 minus 1 by 12 becomes 11 by 12. See, 11 by 12 na? This one is, okay. So whole answer for this one we have 3.14 or 4 by 12, but we have 4.18, right? 4.18. Okay, I'm writing here. This is equal to 3.14 into 4 into 4 by 12 into 11 na? Okay, so whole solution 3.14 into 4 into 4 by 12 we have we have 4.18. So remaining value is 11. Okay, multiplication 11 to 8, 88. Okay, carry over is 8. 11 to 11, 11 plus 8 is 19. Carry over is 1. 11 to 4, 44. Carry over 1, 44.95. This implies nearly 46 square centimeter. Nearly. Okay, round you can find the approximate value. So here also 4.2 is approximate. Here 4.6 is approximate value. For this one also find the length of the arc. Okay. Length of the arc is, what the formula? Length of the arc is, what the formula? Theta by 360 into 2 pi r. This implies, so 330 by 360 into 2 into 3.14 into 4. Okay, this implies 1 by 12 into 2 into 3.14 into 4. 4 3s are 4 1s are. Okay, so the remaining is 8.2.6 by 3. This becomes 3 1s are 3 2s are 2.9. Okay, 9. Okay, 2.9 nearly. 3 1s are 3, 9s are 27. Something else, 1 is remaining, 9 2. So this nearly equal to 3 centimeter. Okay, remaining is again total length by. So measure arc we have 2 pi r minus theta by 360 into 2 pi r. This is 2 pi r into 1 minus 1 by 12. This becomes 2 pi r into 1, okay, 11 by 12. What do you have? 2 pi by r 12. Okay, 2 pi r by 12 we have 2 pi r by 12 into 11. 2 pi r by 12 we have, this one is answer, no? This one. Okay, 3 into 11. This is equal to 33. Okay, 33 centimeter. Okay, 36. Okay, to collect the clarification, just put the value here. Total circumference is 2 pi r, 2 into 3.14 into 4. This is 12 into 3.14. Okay, 12 into 3.14 is what? 12 into 4. 12 into 4 is 48. 8. Take over 4. 12 into 1. 12. 12 plus 4. 6. Okay. 12 into 12 plus 16. Carry over 12 into 3. 12 into 3 is 36. Okay. 36. Carry over is 137.7. Okay. We will get the nearest answer. Okay. So here, due to the 1 by 3.14, due to the presence of the real number, okay, transcendental number we call this. Why transcendental number is, it does not have any solution for the does not have any algebraic solutions, right? Due to the presence of pi value, the real number 3.14, the carry over what do you call that? The clarification. Okay, cross clarification. The cross clarification may differ by digits or units, 1 unit or 2 unit, and maybe some decimal values. Okay, so here 33, here is 36. 33 plus 3 na? 33 plus 3 and 33. Here 36. That is okay. Except in an exam, you will give the full complete marks. That's all. Okay. Next, find the area of this segment with a different angle. Okay. So just for this circle, you have to find the area of the segment. Area of the segment, which one? A, Y, B. A, Y, B. Direct with the formula. That's the best thing, I think so. Okay. Just okay, by book they given different methods. Okay, but taken the sector and you have taken the this one. Which one? Area of the triangle. So here we can use the formula. So area of the segment, what we have, A, YB is equal to R square pi theta by 360 minus sin theta by 2 into cos theta by 2. Formula. Okay, in book also you can follow the book, you can solve it that method also, but I am doing to save the time following this one. Now the R is 21 square, or the value of the pi they given 22 by 7. I have take the 22 by 7 here, pi into 120 by 360 minus 120 of sin 60 into cos 60. Okay, this one is 21 square into 0 0 12 on the 12 3 is the pi value is 22 by 7, so remaining is here 3 multiplying 12 on the 12 3 is the, so 22 by 7 to 3 minus what sin 60 root 3 by 2, should take the root 3 by 2, but cos 60 1 by 2. You should remember this value. Okay, so this becomes, okay, 22 by 21 minus root 3 by 4. Okay, 21 square. Right, next simplification is equal to 21 square. Okay, LCM take here 4 into 22, because LCM is 21 into 4, minus 21 into root 3 by 21 into 4. This one is 21 square into 88 minus 21 into root 3 by, okay, 21 into 4. Okay, here also we can take the, right, 21 was the into 21 get cancelled, 21 by 4 into 88 minus, okay, 21 into root 3 square units, whatever it will be, square centimeter, not square units. Okay. See, in book no, again they given something else, they taken 21 by 4 no answer, 21 by 8 side. So only 3 to 4 steps this one is, right? Okay, now only just remember the formula, pi into theta by 360 minus sin theta by 2 cos theta by 2, that's all. Okay, just only for the understanding purpose, take this step by step, find the area of the sector. Okay, find the area of the sector, then find the area of the triangle, and difference, take the difference of the sector minus this one, area of the triangle, you will get the exact value. Or only for the area of segment of the formula, r square pi theta 3 by 660 minus sin theta by 2 cos theta by 2. You can use the formula in exams also. Just write the required area of the segment is equal to r square into pi into theta by 360 minus theta by 2 and theta by 2, where theta is the angle and r is the radius of the circle. That's all. Put the value, solve the equation. That's all. Okay. In next class, okay, in coming class, we'll solve some examples based on this section. Okay. Okay. I'll see you in next class. Thank you. Bye.